And for me, being an owner, a whole lot of fun. I didn't know you put wood in the aircraft.
Absolutely, it emerges out of here an actual airplane. If it's polyfiber, it's going to bounce in and out of the paint booths, getting its sealing coating and its silver UV protection on it. And then once it's done in the paint booth, it'll go in this door, it'll come out this door over here, and then it'll roll backwards into Station 7 over here.
Fly high, touch the sky. Flying forever, reaching for the
So the final assembly building, it looks like this is where it all starts. Can you kind of walk me through the steps in the building here, what happens and the process?
We have 12 stations. The aircraft is going to cycle through those stations on attack time. So every so many hours, that line is going to cycle. Each aircraft will move to the next station on this. In Station 1 here, we're going to check that fuselage. We're going to make sure there's no dents, stings, or scratches. We're going to clean it really good. And then from an order of operations standpoint, we're going to start putting our socks on before our shoes and our pants on before our shoes. We're going to put stringers on, fuel lines, electrical floorboards, etc., in order to do as much as we can before that fabric goes on. And the aircraft is going to stepwise progress through the whole system, getting a series of components added through those 12 stations till it emerges in the end.
So how long does it take to usually go from this end of the building out the other end?
It's roughly 60 days. It ebbs and flows depending on what our rate is.
So when it leaves this building, it's pretty much an airplane.
It's an airplane, yep. It's been run, it's been taxied, it's all its compasses are dialed in. It hasn't been quite flown yet, depending on what type of aircraft it is, but yep, absolutely. It emerges out of here an actual airplane.
Can we do a deep dive into every one of these steps? I'd really love to show everybody what it's like here.
Absolutely.
It looks like we got a bunch of the sub-assemblies that we saw in the other parts of the factory. This whole floorboard we saw over in the machine shop. They put the rudder pedals in, all the carbon fiber pieces are together, some of the components are in, torque tube. This comes from the other building just as it is?
That's right, it comes from our weld sub-assembly shop. The idea is to reduce the amount of labor at this station. We bring this whole assembly as it is and drop that in and attach that to the airframe. So they're not having to do all the rivets and all that over on this side.
The components I guess we have here that people would be interested in is, obviously we got our two sticks here.
Yep.
Pilot, co-pilot.
Yep.
We got a torque tube that's running through the middle here that attaches the two sticks together.
That's right.
Now what I didn't know is, seeing this, is I see how the cables now work. I thought maybe there was two cables here pulling back and forth or up there. So you got the cable here to put the elevator forward, cable in the front that when we pull that, puts the elevator down. So that's pretty interesting how all that works. Never able to see that. And then we have the same thing here with our rudder pedals and brakes. Brakes aren't in yet, right? That's hydraulics in this plane?
Yep.
What's this plane? Looks like a UL?
This is a UL, that's right.
Okay. And we see the same thing here. We got our cables.
Yep.
Cables going all the way back down through the fuselage here to the back. We'll head back there and look at that. And our pulley systems are getting put into place.
Yep, pulleys are in, yeah.
And then another indicator that this is a UL versus an FX3 or a Carbon Cub, there's a header tank here.
That's right.
That I assume helps keep the pressurization of fuel up, like in our Extra and our Game Bird, so that you don't have any air in the lines or anything from tanks that gravity feed down into the header tank and then feeds the engine. Okay, so as we move back, we can start to see cargo area behind the passenger.
Yep.
And then behind that, we have the cargo area we access from the back of the plane.
Yep, we got our baggage door here.
So if we move to the back here, so obviously I can see the clamps in here, all the pre-wiring done like you talked about before the fabric goes on. Looks like we've got our rudder cables that are just hanging here right now, correct?
Yep.
Electric trim system?
That's right, your trim system's all in place. So
position indicator?
That's right. And then you got your motor actuator below with your jack screw here.
Okay, and then little spring on here to give the trim system some tension.
That's right.
All right, and then so we're gonna have our feathers will go on here, and then
it will get covered. So your rudder posts, everything. The rudder will be fit to the aircraft, so it's essentially custom fit to the aircraft. So we know that it has appropriate swing.
So at what point will this now go to the next station?
That depends on our tack time, that can vary. But after that tack block, that's gonna shift the next station. So the way we organize that is if we want to build X number of aircraft in a given period of time, we break the labor hours up to say we're going to build, say, 25 hours. 25 hours of labor takes place in each station. So after 25 hours, the airplane shifts to the next station.
If you're in the Builder Assist program, you at least get to come here and really see the inner workings of your aircraft as it's moving through production,
Yeah.
which I think is invaluable without a doubt.
Absolutely. To see it from the inside out and every nook and cranny of an aircraft makes a big difference when you have it in your hangar and have never experienced that or never seen that. So this is where all the harnesses for the aircraft are built.
Now, somebody told me that this is where you started 13 years ago.
Yeah, I part-time in machining school, and
This looks kind of like a one-to-one kind of pattern. How does this work?
it's exactly what it is. So, try to make it as simple as possible and as easy as possible, both to follow and build. So it identifies of course, your labeling, what the wire is, and its identification, what hardware goes on the end, keeps it in place so it's quick, easy, and visual, both easy to build and easy to verify. Thinking of it as a map, and you want to get someone to a specific place on the map, you want to give them very specific instructions and very specific waypoints along the way so they know exactly where they're at.
I see we've got our comm antennas that are
Yep.
going here
Yep.
that are terminated there. We got our G3X adapters that are here.
Yeah.
Transponder going on here. Which airplane is this?
This is a G3X harness, a modular G3X harness. So this could be anything that's getting a G3X likely is going to get this harness.
Okay. Let's go look at a more complex one. I want to see what else is in there.
All right. So any of the ring terminals or ink connectors or solder sleeves or pins, everything is ideally located right at the board, so the technician doesn't have to travel far to get what they need to complete a harness. So they've got the workbench, they can bounce back and forth with their cart as they're building. And, kind of everybody gets a different feel for how they want to approach building the harnesses. One of the common methods is you run all your wires bare first, and then you work through, maybe start at the top and work your down, doing all your jumpers and your ground wires and cannon plugs and whatnot. So just different approaches to it.
Okay, so it looks like they've got all their ping sequences here.
Yep.
The numbers correspond to, the different connectors here?
Yep, yeah. Every single point's identified with what goes to that specific wire.
So how do you test this harness once it's done?
Typically, it's tested in the airplane to validate. We'll go through, validate that everything's labeled properly. If we have to, we can do ground out testing if we need to, or ohm testing, make sure there's continuity on the wire. Pull tests occasionally on end fittings and as needed.
So is that like ringing out the wires to
If we need
thing
to.
each end, they'll find them and things? Mm-hmm. That's really interesting. I love how it's kind of like real size, real time. You can just see it and build it right there on the
Yeah, it's
board.
beautiful. It's and one of the things that I enjoy and I see even in this now is 13 years ago when I started working on these and building these, we didn't have, for instance, these little captures. And somebody found them and we tried them, and then we made some of our own, and we did different things to improve the process. And that was really where I started the process of learning, like, hey, here's how we continuously improve something. And the way we've built them has gotten better and better and better. And collaboration with our engineering department, the way they set up the prints has gotten better and better and better. So process of just constantly refining things little by little by little is a lot of fun.
So then this comes off the wall and goes to final assembly.
Yep, gets either staged in the warehouse or goes right down to our Station 3 Avionics install, where they start putting the panel in and getting the whole harness installed in the aircraft.
Here in Station 3, and what starts to come together here? It looks like avionics, electronics, fuel system.
That's right. So this station is primarily avionics, wiring harness installation, getting the panel installed, getting all your plugs ready to get connected to your instruments, etc.
This looks like a UL, I can
Yep.
see here, obviously from the panel and the switch.
Yep.
And the instrumentation for the engine.
Yep.
Looks a little different than what I'm used to in like an FX3, a Carbon Cub FX3. Because in the FX3, this battery backup is an IBBS, correct? And then there's an additional battery in FX3 for ignition backup.
Yep.
You don't need that on this airplane.
Right.
And then I see we got our battery box here. So FX3 UL batteries here.
That's correct.
XCub, where's the battery?
The battery is aft behind the baggage compartment.
Okay.
Yeah.
What are these solenoids and things I see going on in here?
So starter solenoids that connect into your ignition switch. So that's gonna route power to your starter briefly and get the engine running.
So it looks like a lot more innovation when it comes to the UL that I'm seeing in place here.
There's been a lot of work into the UL to, of course, optimize weight and for instrumentation. And of course, for the Rotax, that was a departure from your classic Lycoming 4-cylinder. It's a 4-cylinder opposed engine, but it's computer controlled, much more advanced than the traditional horizontally opposed 4-cylinders of aviation normalcy.
And also, I guess we'll see it down the line here a little bit more because there's only one lever in a UL, but this is full FADEC, correct?
That's right, that's right. Your prop and your throttle are bound together.
Fuel system, everything's all computer controlled.
That's right.
So on this side of Station 3, I can see some stuff that I saw in the subassembly area, which is in avionics. We saw these harnesses all being made over there, right?
Yep.
That's what we got here. You've got the paneling temporarily, but now we're starting to see the fuel system kick in. Can you tell me a little bit about like how this fuel system works?
So you got your fuel selector, you got vents to your tanks, you've got gravity flow from your main tanks down into your header tank, through your switch, down into your pumps in the boot cowl.
I see we got some sumps here.
Yep.
I know some of the CubCrafters aircraft have left, right, all off,
Yeah.
and some, what's this one? Is this off, left, right?
I believe these are off, left, right. FX3 has both.
Has all. That's what I love about the FX3,
Yeah, yeah.
has the all.
Yeah.
And then the XCub, I think, goes to left, right, off. Okay.
yeah.
I love you guys are using a combination of aluminum lines, and then as we go back here, I can see, this looks like some kind of, I didn't know you put wood in the aircraft. What is this here?
Just so shop aids, so these are our jigs and devices that help us build the airplane. In this case, what we're doing is locating the comm harness. So your LEMO jacks and your regular mic and headphones jacks are located as to where the final header panel is going to be installed.
And then this will end up being a carbon fiber piece?
No, that'll be an aluminum piece.
This is just here temporary to help you get the wiring in.
Yep,
And is this pretty much everything in Station 3 before we go next?
that's right. Yep.
All right.
You know, your systems will be tested and dialed in and made sure that radios are working and G3Xs are powering on and whatnot.
And that happens in this station?
That's right.
So Station 4, this looks like a piece I saw over in the carbon fiber facility, yeah?
That's right. This is a composite boot cowl that was built over there and then firewall installed on it. Got a few other components added to it and brought to the main plant. And in Station 4 here, this will be fit to the aircraft.
What else happens in Station 4?
So 4 is going to get into all the interior panels are going to get drilled to the fuselage or match drilled into the fuselage. So fit, dialed in so they fit perfectly in the aircraft.
This is kind of a piece here, right?
Yep. That's one of our panels.
Before we leave Station 4 and go into Station 5, I see it's kind of tight throughout here. I mean, how do you get the airplanes from station to station? Like, how do they flow?
So everything in the facility is on wheels, so we can move any benches or anything out of the way that we need to move aircraft. So from Station 4, the aircraft is going to flow back into our cover area. So tail feathers, wings, fuselage, everything, whether it's polyfiber or Oratex is going to be covered back there. If it's polyfiber, it's going to bounce in and out of the paint booths, getting its sealing coating and its silver UV protection on it. And then once it's done in the paint booth, it'll go in this door, it'll come out this door over here, and then it'll roll backwards into Station 7 over here. And then it'll begin further installation of components.
Let's head over to that area because that looks exciting to me where wings are starting to come together.
Check it out. Here we pass by some paint carts, so you can see raw aluminum parts. These came off our router on the other side, rubber pad press. They're staged and ready to be scuffed and primed and painted. Here you have a set for an aircraft that'll come out and hit the line. This cart is being painted, prepped and painted. At the same time, the fuselage is being covered and painted so that they can meet each other at the same time on the line.
Can you kind of tell me what do you got to do to prep the wing? I see like all kinds of different tape and they're brushing stuff on there, but how do we get this ready?
So this is a polyfiber wing. The tape here, that's to protect the fabric from, you know, a protruding object, you know, rivet in this case, that if too aggressively handled could rub through the fabric. We don't want that to happen, so tape goes on to protect any hard edges that could potentially damage the fabric. You've got a stabilizing band that goes through the ribs to make sure that the ribs can't twist. Of course, they're all protected from any fatigue at their joints. Down here, we've got some glue that's curing, that's being prepped for fabric that'll go around the landing light area.
How much of a difference is there between Oratex and Poly-Fiber? You know, do they have to do different things on the wing?
Prep's totally different, yep. So with Oratex, what we're gonna do is any surface that's gonna get Oratex bonded to it is gonna get scuffed, of course cleaned very good, and then get a primer coating on it that then the Oratex goes over.
From a glue standpoint, is it different?
Totally different types of glue, totally different type of process. So the Oratex is a heat-bound glue. When the fabric is in place, you're gonna adhere that fabric with heat and pressure that bonds those glue layers together.
It's dry to the touch before the fabric goes on, and then the heat activates the glue that brings them together?
That's right.
And then if it's Poly-Fiber, you're putting anything poly brush on before?
Yep. You'll put your poly brush on before, get your fabric oriented in place, saturate it, and then go through with your tapes and eventually shrink things, get your fabric rivets in, get your reinforcements in place, your patches in place. Right now they've got the top fabric on, and they're getting the forward edge, leading edge set up for the fabric to wrap from the top to the bottom. They're just getting that seam dialed in so it's clean and neat and in place, and they can start tacking things in. So they're just temporary adhering it with tape to make sure that they got it in the right place.
So what's the difference? I see that what she's using right now looks clear versus the pink that I'm used to seeing.
Right, that's the Polytac product, so that's going to initially adhere the fabric to the wing.
So it gives you the ability to put the fabric on it, keep it tight, and then the poly brush has got the pinkish look to it that goes on top.
The poly brush is going to ultimately in the end be the sealer that seals that fabric and keeps, you know, any rain or whatnot out of your fabric.
So I see the pink here. So this is not Oratex, this is poly fabric. But is there Polytac here, or how do they get these areas ready?
No, so there's no Polytac here. So what we'll do here is we'll put a reinforcement tape that has an adhesive already on it. We'll run that down the length of the rib, and then we'll rivet through that reinforcement tape, and then we'll run a 2-inch tape will get glued and adhered over the top of that whole assembly, which solidifies the whole structure and doesn't allow the ribs to twist or bend at all.
And then we put poly brush over the top of all that?
Correct, it'll get poly brush over all of that, and then it'll get poly brush over the whole wing.
But before they do that, they're ironing it to pull it all
That's
together.
right, to shrink the fabric and get it tight.
Okay, great.
So right now we're adhering 2-inch tapes and then cleaning up any glue lines to make sure you have a good crisp edge to your tapes. This is different from our Poly-Fiber. This is the Oratex product. And so we're going through making sure our tapes are adhered very tight and very clean and sealed. It's a tedious process, but in the end it produces a beautiful, strong product. We looked at the wing earlier that didn't have tapes on it yet. Now you can see the progression in the process where you have your reinforcement tape underneath, you have your rivets binding that to the rib, and then you have a 2-inch tape over the top of that. And then we've got our sealant over the top of that whole structure. And you can see now a tape is being added here, which will cover that whole leading edge and capture and keep that whole leading edge clean and strong. So now we're in the paint booth. Here we have tail feathers that are with a beautiful metallic paint job on them. We can see, we came out of our cover area. You can see our reinforcement tapes. You can see where everything it is, but it has a beautiful consistent paint job on it. So from here, it's gonna go one of two ways. We're going to lay out, if there's an additional paint going on these for a second color, we're gonna mask that. We're gonna scuff that area. We're gonna protect the other area, and it'll come back in here and get painted with its other color. Or if it's done and this is the only color that's gonna be on it, we're gonna cycle out that door and we're gonna stage it to meet the aircraft on the line. So let's head that way. Okay. So this is part of our paint area where you've got an aircraft here that's being prepped for its second coat of paint. So it's already had one coat over the whole aircraft. That base color is underneath the paper here. And then up above, we've been scuffing and prepping that upper area for the second color.
Okay, so then if you're doing any kind of striping or multiple layers, this is where that would happen, and it comes in and out of the booth?
That's right.
You don't do any like compounding after or clear coats? You really don't need it the way you guys do your paint?
That's right. We try to keep it as light and as durable as possible.
About how many layers most do you ever really do on a paint job like this?
Typically, if we can get a complete coat in one shot, that's what we want. Sometimes we got to go over with a second coat, and it really depends on the type of paint you're using, the color the paint is, whether it's a metallic or non-metallic. So there's some variables, but if we can get a single pass over that, or a single block of time in the paint booth where it's not in and out of the paint booth for cure cycles, we prefer it that way.
Okay. Well, I see some metallic over here. I want to check
Yeah.
this out. This looks awesome. Obviously, this has got some metallic here, but I also notice the carbon fiber. Like, how do you get that look?
When we originally go to make this part, we're going to take and spray clear gel coat into the mold in the specific area that we want to showcase the carbon fiber on that particular part. So we'll mask that area on the actual mold, spray it with clear coat, and then go back over and spray the other areas with the black gel coat. Then we go in really carefully. We showed early on where we're laying out that loose weave carbon fiber. We'll lay that in those areas really carefully so you don't get any distortion of the weave, and then go through our normal process of pulling a vacuum on it with our media, our flow media and our bagging film, and infuse that with resin. In the end, it pops out. You see the beautiful, clear carbon fiber aspect of it.
So very intricate, and that goes back to when we were over in the carbon fiber facility. Now I pull it together. You call it gel coat over there, right? It's a
That's
clear
right.
coat, gel coat, same thing?
Yeah, there's different colors of gel coat.
So you really have to be thinking ahead in the manufacturing process that if you want the end piece to look like this versus maybe just all, you have to be thinking about that way in the beginning process of building the aircraft.
That's right. It's from the initial, that first technician who's going to start that layup process, or even before that, the technician who's prepping the mold has to know that this is the intended outcome.
Another example of where the word Carbon Cub came from, because it's loaded with carbon fiber, even though people can't see it.
You don't always see it, but it's there.
Okay, great. We're in the engine prep section. I'm sure you guys are prepping a lot of engines every year, but what are some of the things you have to do to get it ready for a CubCrafters aircraft?
So it depends on the engine, of course, but the engine's going to come in a wood crate. We're going to pull it out of the crate. We're going to get it on an engine mount. We're going to take off some of the stabilizing structure that it's been shipped with. Sometimes they come with a preservation oil in them. We're going to pull that preservation oil out. We're going to add any of our ducting or the plenums onto the engine as required. Start hooking up some of the various systems to get it prepped so it's as easy as possible for the technician to install it on the airplane with minimal work on the engine.
Okay, so you said something important, how your plenums are going to be, what you could do for airflow. I mean, the Rotaxes are liquid cooled, so you probably don't need to duct the air as much as you would need for like the Lycoming, the Titan engines and things, right?
Yeah, so on the Titans or Lycomings, you're going to push cool air down through the fins. These don't have that. Of course, you have a radiator that you want to push air through and give a place for that air to come out of the cowling, but very, very different system compared to a Lycoming.
So is the outside shape of the cowling different between the engines, or it's just the inside?
No, the outside's different. The cowling's it's a unique cowling to the engine. Yep.
And you guys had to engineer that perfectly to keep these cooled, right?
Absolutely, absolutely. A lot of work goes into making sure that the engine stays cooled properly and looks good and hits all the right buttons.
So it looks like we get the aircraft from 4 to 7. In between here, this engine's getting prepped and it drops right into Station 7.
That's exactly right. So that means that when the aircraft comes out of paint and meets in Station 7, that engine is ideally exactly ready at that moment to go on the aircraft.
That's efficiency.
That's what we strive for.
Station 7, what happens here in this station?
So we're going to get our interior panels are going to be installed in the aircraft. We've got the ELT is now in, the battery's been installed. We got seat belts put in place here. We're getting the windshield fit. The windows are going to go on. Now our header panels are on, and our comm harness here is staged, so that'll be fastened up to the header panel. We saw we only had it with a shop aid previously, so now that's set in the exact right location to get those attached. 25 to 30 hours worth of work, and it'll cycle to the next station.
This plane, you can see why, or the things that make this different than the UL. So this is an FX3. with a level 1 IFR panel. So this won't be ILS, but it'll be level 1 IFR.
Autopilot and you know, a moving map and all the bells and whistles that you'd see in a fancy airplane.
Okay. And the difference in this plane is we've got prop control, throttle control, where in the UL it's the FADEC, so it's one lever.
That's right.
We got mixture, which you don't have in the UL. So this looks more like the XCub. And this is the IBBS switch we were talking about here.
Yep.
This is the battery that drives the IBBS system. So that's how we can kind of see the difference here. So it's really starting to get fun. It looks more like something I'm ready to jump in and go fly.
It's close, and it speeds up. We can usually make up time between these 3 stations and kind of compress them together, and because now it truly is becoming an airplane, so it's larger assemblies going in. It's not as much of the small, tedious handwork.
Okay, great. And we're getting pretty close to the wing, so let's go on to number 8.
The aircraft is coming more and more together. The gear have been installed, tires are installed, shocks are on, engine and prop are on, spinners on, windshield's now buttoned up, the door's on, seats are installed, seat belts are in up above, windows are going in, baggage is on, tail feathers are on, tail wheels on. So now you really are an airplane, just no wings yet. So everything's getting prepped for those wings to go in. It's getting close.
Okay, let's take a closer look inside.
Yeah.
Now we get to finally see at least the inside in the cockpit in its final position.
Yep.
This plane is the FX3, right?
That's right.
I can tell you from my own experience, the reason I love that IBBS is because before I get in the airplane, or even if I'm stopping somewhere to fuel, I can flip that up, leave it on, and it brings all my avionics up, gets everything all energized before I even get in the plane. So when I get in the plane, my engine instruments are up, and then I'm ready to start. I love that switch. I like it. I know that as battery technology has evolved, and even in the XCub with the newer lithium-ion batteries and stuff, it's like you almost don't need it as much anymore, because I can tell you in my XCub, I've left my battery on overnight with all my equipment running, came in the next day, discovered it, pulled it out, started the airplane up and flew, no problem. So the battery technology is definitely getting a lot better.
Definitely, that's a new battery, not the old batteries.
No, it's in the XCub, so it's definitely one of the newers. So over here we've got our aux fuel pump, so that's our boost pump. And then there's 2 pumps in this plane, correct? We got our boost pump, and then we have our engine-driven pump. So here's our emergency ignition switch. So if I did lose power or any battery issues, I can flip that up and I can still get ignition and fly. About how long do I get on that if I need it?
We're looking at about 45 minutes.
That's enough when I'm flying at 500 feet to get on the ground.
Find somewhere to land.
We talked about IBS, of course we've got our master, our avionics, and I see we have pulse on our landing light. So what are the different formats that I can get my landing light in?
So, there are options, so people will choose not to have landing lights at all. In this case, we have solid or pulse. So big bright LEDs, light everything up.
Okay, so we got pulse lights, we got our nav lights, strobes, and then our servos.
Autopilot servos.
So this is not an IFR panel. What do we have here?
So 3D printed, you got trim control here, you got autopilot disconnect, and then you got comm up front on the trigger.
Okay, and then on this side, of course, we got our mixture. And is there an option on the mixture handle which we can use?
Yep. A lot of people prefer the vernier. I think it's pretty common. So there's a few different types out there that people go with.
Okay. Then we got our throttle and prop.
Prop, yep.
I see other stuff happening here.
Yeah, you got a throttle lock, so you can lock your prop and your throttle in position, if you're on a long cross country, and you can lock that into place. You don't have to be hands-on every second of the way. You got your fuel selectors in place, a bunch of your decals have gone in, you've got your limitation placards are in, your end number placards on it. So all the little tiny details are starting to come together too.
Okay, and I know we talked about a few stations ago.
Yeah.
Your mixture, this one has, FX3 has all, left, right, and off.
That's correct.
And it's different for the different aircraft for other reasons.
Yeah.
So, and then we get to the back seat here. Rear passenger, how many different options and seats and things do we have?
So this is our normal sling seat. We can get different cushion combinations. We do have a hard aft seat kit that we manufacture.
Hardware changes for that? What is it?
It's a pretty substantial change out. Yeah, it makes it a very different. It uses some of the same hardware.
I know we're missing the stick right now, but what other options do we have on that?
Your aft stick, you can have trim and calm in the stick. Right now we got it up in the panel, so that's an option.
So push the talk for passenger here.
Yep.
So what's this switch here?
So trim priority, so you can set whether it's the pilot or co-pilot that has control of the trim in the aircraft.
If I like to fly from the rear and my wife likes to sit up front and watch, then I can flip it to back and then my stick will control the trim.
That's right.
Or if maybe you got an instructor that's teaching you on airplane or something like that, they're able to, to make that switch.
Yep.
That's pretty good.
Yep.
And then in the rear seat, we also have throttle and prop. Now, no mixture back here. The mixture is only up in front.
That's right.
Really comfortable. I know I've sat in this seat a few times, and I love the sling seat like this.
Yeah.
Great. Can we take a walk around, see what else goes on in this station?
Yeah, absolutely.
These are 31s?
These are 31s.
And what's the different options we can get in tires on?
So there's a few different manufacturers and a lot of different sizes of tires you can run with. 29s are pretty common. People go all the way up to 35s.
29 and 30s, we got one size of wheel on the tires, but once we go to 35s, now it becomes a whole different animal, correct? Because we have to change the rim out. Then we also have to change out the brakes.
Yep, they'll usually do
To
full
larger.
caliper brakes.
Dual caliber brakes. Okay. And then the gear itself, I mean, you guys make all this in-house, correct?
We make the steel gear in-house, that's right.
And then there's also other options for these?
There's titanium options through a couple different manufacturers.
And then how about our shocks? These are Acme Aero?
These are Acme Aero shocks, that's right.
That pretty standard on this
They're
plane?
pretty common, yeah. A lot of people go with Acme Aero.
You talked before about these are like, is this a 3x3?
This is a 3x3 gear.
So what changes on this if you don't have the 3x3? They get a little shorter?
Yeah, a little shorter and a little further aft. So this pushes them out a little further, gives you a little bit longer relationship to your tail with us.
Okay. Now, I've seen some of the aircraft in here that are really cool that this all has the fabric that matches the plane here.
Yeah.
Is that an option?
That's an option, yeah. People will choose sometimes just painted and raw like this. Looks pretty good in my opinion. I like it both ways, but I like them bare like this. Some people with a titanium, a lot of time people don't even paint the titanium, it's just bare titanium.
Okay. If they have the fabric in here, is there any advantage in air speeds or anything?
I don't know of any. I've never heard of any advantages like that.
Can you kind of just walk me through some of these components? I see like these rubber things in here. Like, what are these pieces?
Yeah, so the tail feathers have been installed. You have a gap seal in here that just keeps continuous airflow over the control surfaces. Doesn't allow as much turbulence to be generated by that gap between the elevator and the horizontal stabilizer. Your tail brace wires are installed and tensioned, so that keeps that whole structure rigid and solid. Tail wheels installed. It's got an Acme Stinger on it. Nav lights in, trim tabs on.
Probably a handful of different options that we can get on here based on what our mission is, correct?
Absolutely, yep.
Okay.
You can get bigger, smaller. You get the big beefy for getting on the gravel bars and bouncing around cobble rocks up in Alaska.
So these can take a beating, and they're pretty stout as they are.
Absolutely.
Starting to really come together. I'm almost there where I'm going to get excited about the wings coming on. So let's head over to the next section.
That's the next step.
So I'm seeing a sign, Section 10, wing prep.
What we're doing now is getting everything dialed in on the wing for it to be mated to the aircraft. So we're fitting tank lids. We're installing just the padding underneath the tank lids. You see the fuel caps on now. We're painting the wigwag enclosure flat black. We've got our grommets on, and VGs have been installed here. So everything that can be done to this wing before it goes on the aircraft is getting done here.
Okay, great. And I see a whole bunch of other components over here.
Yep. If we look back at our paint prep area, here's another one of our paint carts. So all of those piece parts that had to get scuffed and primed and painted are all staged here, waiting to go onto the aircraft.
And I see a lot of finishing components here as well.
That's right. That cart's come out of our material control area. So that's got all sorts of various things on it that will just the last bits and pieces that go onto the aircraft.
Okay. Then they get married to the
That's
aircraft.
right.
We're finally at the end of production of the airplane, but not the end of the line for the airplane.
Yep.
So what happens here in the last step in final assembly?
So we've got the wings on. We're going to go in. We're going to connect all the electrical, all the fuel systems at the wing root. We're going to install our tank lids at the top. We're going to button up our skylight. We're going to install our flaps and ailerons and get those rigged and tensioned properly. Make sure they have the correct throw. Test our fuel system. Make sure our fuel system has integrity by loading the system with some fuel. And then eventually the aircraft's going to be taken outside. It's going to be started up for the first time. and we're going to validate that all our sensors are working properly, that all our instrumentation's working properly. We're going to swing the whiskey compass and the digital compass, make sure that they're talking to satellites, make sure that the radios are working. So just a bunch of systems checks. Taxi the aircraft around, make sure the tail wheel breakout's working properly, make sure your brakes are working right.
So basically, when it leaves this door, it's an airplane ready to go, but it has just a few other little things to do after this
A
point.
few other little things before it actually gets a test flight on it.
And then we're actually going to get over to the completion center and to some other areas of CubCrafters to see kind of where the delivery happens and everything
right.
else goes on.
And that's where it's going to get its first flight over there as well.
Hey Patrick, great to meet you.
Hi Brian, welcome to CubCrafters. We're in Jim's original office, our founder. There's a lot of legacy here. You know, example, Jim started this company in 1980.
Now, I think I see a PA-18 frame in there. Is that what that is?
That is exactly what it is. This right here is where it all began, in this small hangar behind that wall right there.
I see some really cool things looking like my old plane over here. Let's go.
All right.